There is a principle in engineering that more is not always better, that the optimum is not the maximum, that the machine best suited to a task is often not the most extreme machine available, but the machine whose capabilities most closely match the task's specific requirements, without excess that adds cost and complexity. The Komatsu D475A is an engineering marvel, the largest production bulldozer ever built, a machine of extraordinary capability. We discussed it at length in Video 5. But the D475A is optimized for a specific set of conditions: large, flat coal mines, long push distances, soft material where economic scale justifies the premium cost and operational complexity of the world's largest dozer. Outside those specific conditions, the D475A's size becomes a liability. Its turning radius is too large for complex terrain. Its haul road requirements exceed what many operations provide. Its premium cost is difficult to justify when production volumes are lower. The Komatsu D475A is the answer to all of those situations. The machine for operations that need maximum large dozer capability. At approximately 108,000 kilograms operating weight, smaller than the D475A but substantially larger than most other production dozers, the D475A occupies a position in the market that is far more commercially significant than the D475A's ultra-specialized niche. More D475As work in mines, quarries, and construction projects around the world than D475As. More operations can justify the capital cost. More applications can accommodate its dimensions. More maintenance teams have the expertise to service it. The D475A is not the most impressive machine in this series. It is one of the most important. But before we get into what makes it excellent, the engine, the transmission, the blade options, we need to understand the competitive context it operates in. Because the D475A competes directly against the CAT D11, and that competition, between the world's largest manufacturer's most successful dozer and Komatsu's entry, is one of the most closely watched. It is a competition that has been running for decades. Neither machine has decisively defeated the other. Both continue to sell successfully. And this reveals something important about how mining operators actually evaluate and purchase large equipment. The D475A and the D11 are more similar than their origins suggest. Similar in weight class, blade capacity, and engine output. The differences are real but subtle. Understanding why they matter requires the kind of detailed engineering analysis that most skip over. The Komatsu D475A8, the current production variant, has an operating weight of approximately 108,000 kilograms in its standard configuration. The blade width is approximately 6.227 meters in the standard semi-U configuration, very close to the CAT D11T2's 6.2 meters. The blade capacity is approximately 38 cubic meters, again close to the D11's 37.8 cubic meters. These near-identical dimensions are not coincidental. They reflect the market reality that both machines are competing for the same customers in the same applications, and that the application requirements define an optimal size that both manufacturers have independently converged on. The D475A8 is powered by a Komatsu SAA12 V140E7 diesel engine, a 12-cylinder unit producing 890 net horsepower. This is somewhat more than the CAT D11T2's 850 horsepower, a modest advantage that Komatsu markets as a differentiator. In practice, the power difference is small enough that it is rarely the deciding factor. Both machines have adequate power for the applications they serve. The D475A uses a Komatsu-designed power shift transmission, the same general architecture as the CAT D11's unit. Multiple forward and reverse speeds, automatic shift under load, electronic control. The specific gear ratios reflect Komatsu's engineering choices. The modulation of shifts is one of the areas where the D475A and D11 differ in ways that experienced operators notice, but specification sheets do not. The undercarriage of the D475A uses Komatsu's SuperTrack, sealed and lubricated track links with specific geometry. The track shoe selection available covers the same range as for the D11, different widths and profiles for different ground conditions. The hydraulic system controls the blade lift, tilt, and angle. The blade control response reflects Komatsu's specific hydraulic tuning. Operators typically describe slightly different feel between the two machines, different in ways that reflect different hydraulic tuning philosophies. The D475A is equipped with Komatsu's Intelligent Machine Control System, GPS-based grade control used for high precision. The system automatically controls blade position relative to a design-grade surface, reducing the number of passes required. The ComTrax Plus telematics integration provides the fleet management and predictive maintenance capabilities that are now standard expectations, and this is where things get crazy. The introduction of the Intelligent Machine Control System produced an outcome that was somewhat surprising. In precision applications, the automated blade control improved not just grade accuracy, but also fuel efficiency. Fewer passes meant less fuel burned. The automation was improving two performance metrics simultaneously: accuracy and fuel consumption, reflecting the compounding benefits of well-designed automation. The comparison between the Komatsu D475A and the Caterpillar D11 is the most closely watched competitive matchup in the large production bulldozer category. Both machines are deployed in the same mines, the same applications, by the same operators, often in adjacent work areas. The practical performance differences have been observed and quantified by mining operations that have deployed both machines and measured their productivity. Reliability and maintenance costs under identical conditions consistently show performance differences are smaller than either manufacturer's marketing would suggest. The deciding factors in real purchase decisions are more often existing dealer relationships and the maintenance infrastructure already in place at the mine. In mines with established Caterpillar fleets, the D11 often wins purchase decisions because the infrastructure, training, and parts inventory already exist. Adding more Caterpillar equipment is simpler and less expensive than building a new support system for Komatsu equipment. In mines standardized on Komatsu, the D475A wins because it fits seamlessly into the existing Komatsu support structure. This infrastructure dependency influences equipment purchasing decisions independent of machine-specific engineering merit, defining a key dynamic in the mining market. Neither can displace the other from accounts where the competitor's infrastructure is deeply established, keeping the market relatively stable. The engineering differences are real. The hydraulic tuning difference, the feel that experienced operators notice, is consistent and reproducible. Specific transmission shift quality and undercarriage component life in different material conditions also show measurable differences that vary by application. But these differences do not produce a consistent advantage. Each machine has conditions where it performs marginally better. The aggregate is essentially equal performance at essentially equal total cost of ownership. This competitive parity is itself an engineering achievement. Both manufacturers have worked for decades to address weaknesses while maintaining strengths, resulting in two essentially equivalent machines. Engineering diversity is more valuable than a single dominant design. It drives improvement and ensures that operators have a genuine choice. The next generation of both machines will be better than the current one, pushed by competition to improve rather than comfortable with dominance. The Komatsu D475A is deployed across the same application range as the CAT D11, large surface coal mines, copper and gold mines, and quarries. Its specific strengths, the intelligent machine control precision, and the ComTrax Plus fleet integration give it competitive advantages that committed Komatsu fleets can exploit. In the copper mines of South America, many operations have adopted Komatsu haul trucks for their AC drive advantages. The D475A's integration with the Komatsu fleet management platform provides system-level visibility that mixed-brand fleets cannot achieve as simply. Mine managers overseeing a complete Komatsu production fleet, PC 8000 excavators loading 980E trucks, can see the complete production picture in a single platform. In Australian iron ore operations, the D475A competes directly and successfully against the D11 in the high-cycle, hard rock conditions of the Pilbara. The comparative undercarriage life data accumulated from parallel deployments has been closely analyzed by both manufacturers and their customers. Neither machine has a consistent undercarriage life advantage across the full range of conditions, leading to consistent competitive parity. In the North American coal market, the D475A has made inroads primarily in operations looking to broaden their strategic supplier base. Single machine comparisons rarely produce a D475A win in established territory. System-level evaluations are more often decisive. The Komatsu D475A is not trying to be the most impressive machine in any category. It is trying to be the best machine for the most applications at the highest production scale where its size is the right choice. And in that pursuit, it succeeds with a consistency that its sales figures over decades of production confirm. The development trajectory for the D475A follows the same pattern as for every machine in this series: autonomous operation and electrification. The intelligent machine control foundation for autonomous dozing is already present in the current machine. The extension to fully autonomous operation, the D475A working without an onboard operator, is the next step. Komatsu has been building capability toward this for years. The transition from diesel to battery electric or hydrogen power will follow industry timelines. This is being set by battery technology advancement and mine operator demand for zero-emission equipment. Komatsu has demonstrated electric drive technology in smaller dozers and is developing the infrastructure needed for larger machines. The D475A's transition to electric power will be a longer horizon development than the haul truck electrification already underway. When that transition happens, the D475A will be more capable, with smoother torque delivery and lower energy costs. The machine that is already the workhorse of the large production dozer market will become even more capable. The Komatsu D475A. Not the largest, not the most dramatic, not the one that sets records, but the one that works. In more mines, on more continents, in more material types than any other large bulldozer in Komatsu's range. That is the achievement that matters most. Next, we move from bulldozers to articulated haulers. These machines carry material where rigid frame haul trucks cannot go: steep grades, soft ground, and tight turns. The Volvo A60H takes the articulated hauler concept and expands it to a scale that challenges current definitions. The numbers are significant. The engineering story is fascinating, and we are just getting started.